This is the second part of Chapter 2 lecture, and let us actually begin playing with the code. Just to remind you how we can open idle or open your favorite integrated development environment. It's going to take a moment on my laptop. Here we go. This is a shell. In a shell, we can execute single commands. For example, print. I want to print something. Print. There is some prompt on what you can do with it. Don't worry if this looks too intimidating. Print hello world. So this is a programming statement. We are calling a function print, and we are supplying an argument for this function. You may begin remembering this verbiage. So what is it that we're supposed to print? Hello world. Notice that hello world was actually in quotation marks because it is something that is called a string that is like literally a text. Alright, so we can print other things just as well. We can print other values, like values. Print the value is 5. Let's look what it does. So the value is 5. Notice that I have print and parentheses open and close. And that's how I know that this is a function in Python. A word followed by parentheses, opened and closed. There can be some arguments inside. In this case, there is 2 arguments. So I'm going to print this, comma. I'm going to also print a number. And by default, we will talk about commas later, but you can print a bunch of things, and the reason why there is a blank space is the default behavior of print. So if you have a comma separated list to print, so I print 1, 2, 3, 4, 5. They will be printed with blank spaces in between. So it's a default separator for blank space. Alright, so that's how you can try something in idle if you need to try something in idle. Idle is in a shell, it's useful, but you cannot write a whole program in there effectively and execute it. So to write a program consisting of more than one programming statement, it's always better to open a file, as I'm doing right now, and maybe save as right away. I'm going to save this one in some folder. I'm gonna call it first prog. So this is my first prog, and I'm going to create it shortly. Alright. Now you can print more than one thing, as I was showing you in the example. By one thing, I mean this is a so-called string literal. I'm trying to highlight it carefully. From quote to unquote. And this is another string literal from quote to unquote. So we are printing 2 strings, comma separated. So print can take multiple arguments, as many as you like, and we need a comma in between 2 arguments. It's going to print as you expected in the same order, and by default separated by a space. Essentially, I already said this. Now there is something called a comment, and I'm going to write a comment. So this is a comment, and triple quote, a single quote 3 times. This is a multi-line comment. triple quote closed. So comments are for humans to understand what's going on. It's a good idea to comment your program. Don't overdo it. You don't need to write an essay. And as you're becoming more competent, and people who read your code, you expect them to be competent, there you will come up with some necessary minimum of making comments as you go. So there are two ways to do it. This is a single line comment and this is a multi-line comment, and after that I can print hello. Single quotes and double quotes both mean a string literal in Python, so you can use either. And to run an entire program, you click run. So the only programming statement there was still print statement, just that. Everything else was a comment ignored by the interpreter. Alright, first of all, data types. There are integers, floats, and strings. There are many more data types, but at least remember these three right away. Integers, int, float, that is your real number, like 2.1, and strings are the string literals that I was playing with earlier. Now, data types can be static, that is when the memory is allocated at the time when they are initialized, or dynamic, where the memory is allocated as needed. Dynamic is slower, but it is more flexible, because sometimes you want to store an entire list of things in one data structure, like one variable, and sometimes you don't, in which case you want to use static. And let's keep the buckets. Here is an assignment. Variable equals expression. That is not mathematical equality. Whatever is on the left is defined by the expression on the right. For example, age equals 22. Variable named age is equal to the number 22. Name equals to Toby. So now the variable name will point to a string Toby. And x equals to 5 plus 4, so x will be equal to 9. And of course, as we go on, we'll see far more interesting variables and data structures. Now, certain common regulations, conventions, what can and cannot be variables. Variables cannot be a Python keyword, cannot contain spaces. First letter must be a letter or an underscore. Underscore actually means something in Python by convention, so don't use underscores freely in the beginning or in the end of your variable. In the middle, it's completely fine. You'll see me soon doing this. Other letters can be letters, digits, underscores. Case sensitive, and names should reflect use. Probably not a good idea in your project to name variables x, y, z, t, and so on. U, W. So if your variable should reference a name of a person, call it a name, and so on. Alright, conventions about naming variables. Camel case, that is the default in Java. Snake case, that is the default in Python. Almost nobody uses Pascal case. It's just here for fun. Feel free to use it if that is the one you like, or if you like Blaise Pascal himself. This guy. Feel free to read about it, about who he is, what he was doing. Alright, variable reassignment. If you assign the variable, you can change it. This is one of the ways to do it, and again, this does not mean a mathematical equality. If this was a mathematical equality, subtract a from both sides, you will have 0 equals to b. And that is not the case. Not. I cannot say this enough. Not the case. Um, what this means is whatever variable value had, whatever value a had, for example, a was 5 and b was 2, now a becomes 5 plus 2, 7. And we will play with it. Actually, maybe we should quickly make an example. Back to shell, because that's the quickest way. So a equals 5, b equals 2. Now I say that a equals to a plus b, and we are checking what is a. I can do it this way. Print a, that is 7, or in the shell, in the console, I can just say a, and it will print 7. In any case, a is now 7, because a was reassigned to be a plus b. Get used to this. We will use this a lot, and also use the shortcut for it. Variables can reference different values while program is running. Asterisk. It's not a good idea to say assign a to b string literal Vlad, and then in the middle of the program make it 5. It's a good idea to keep the type of the variable consistent throughout your program. And again, names of variables should reflect use. You don't need to reassign to the same letter a completely new data type. But we'll see it in a short time. I'll talk about it. Now there is something called garbage collection. Removes unreferenced stuff. I will return multiple times to this point as we go on. Whenever some value does not have a variable referring to it, it's automatically collected because there is no way to use it. Like if you have a name and the name somehow got a name from the user and the name is not stored as a variable, you will not be able to do with this username anything. It will be immediately garbage collected because it's useless. Well, variables can be reassigned from one type to another type, and that is specific flexibility of Python. It can be helpful, it can be very unhelpful, very toxic depending on how exactly you're going to use it. So here is my examples. Here is my string literal. Here is an integer. This is something called Boolean that we will see in the next chapter more closely. And this is a float. This is a real number, 7.5. You can assign literals to variables and use them in expressions. And that's by and large how you do it. Okay. I actually was already doing that over here. So my a was 5, b was 2, and a was equal to a plus b. I reassigned a to b 7. In almost all cases, it's a bad practice, so I'm going to make a comment about bad practice. After I had my a to be a number, I say my variable a is equal to Vlad, for whatever reason. This is bad. Don't be this guy. In fact, I'm going to close this shell now. And that's it. Another useful function, input, that allows you to get input from the user. Result, which is a variable, you can call it anything, name, or whatever the prompt is. Input equal input parenthesis prompt. Example, name, what is your name? Alright, time for the first program. Maybe I'll saved it as prog2 or name prog, because that's what we're going to do. All right. So I'm going to ask the user for their name. And then print comma and user's name. I'll put it like this because there will be actually the user's name. All right, so that's the goal. Input function is relevant because I will need to ask what the user's name is. I don't know who will use the program, when they will use the program. So I need input, enter your name, and then I will need to print hello. Well, I'll say comma. This is a string literal. The next comma is actually a print syntax. So the next thing will be username. And this will not work. We come to this issue now. I asked the user for their name, and I did not save it as a variable. So the first line will work okay, but in the second line I have a problem because I don't have a way to reference the user input. So let me create a variable user name equals to input, whatever the user will enter. And here I will say user name. I'm referencing the value by the corresponding variable that I assigned the value to. So how will this work? Let's see how this works. Enter your name. So Python is started to execute the first line of code. This is the prompt that I provided there. So my name is Vlad. And after I pressed enter, the variable username was assigned a value Vlad that I provided during the program as execution, and then Python printed hello Vlad as expected. And then we can rerun it. And enter your name. I can enter any gibberish. Python does not recognize it's just gibberish, so it works with gibberish. In any case, this is our program that actually do something that makes sense and has more than one line of code actually. Remember, comments are not code. All right. Now you need to know that input always return a string. And sometimes after you have obtained some input from a user, you need to convert it. And there is explicit conversion. For example, if you ask the user for a number, how old are you? The user writes their age. This age is converted to an is not an integer by itself as entered by the user. It is still a string, a text, and you need to recognize it as you need to convert it to an integer using the int function, or to a float if that is what fits your description. Converts item to the float. And let me do it in a couple of ways. So let me save this program as another name. So this is double. My program my program will ask the user for a number and double the number. Alright, so how do I ask the user for the number? Input, enter the number, and then I would like to double that number, which means 2 times that number. And again, I'm missing a variable here. I need a variable here, otherwise there is, what do I double? Okay. So let's call this num. 2 times num, and then print string literal explaining to the user what happened. The double of your number is double. So I created a variable double, which is 2 times num, and it would appear that kind of I followed the natural logic for such a problem. Take a number from a user and double it, and you're good. Make a nice printing statement. However, as soon as I run this, there will be an issue, and let's see what the issue is. Enter a number, 10. The double of your number is 1010. Take a moment, try to figure out what happened. What went wrong? Alright, as I was saying earlier, the result of the input function is a string. So this number, even though I entered 10, is a text. And 2 times text, by default in Python, means duplicate. So what Python did, it's not mathematical multiplication, it's just duplicating the string. And I can show it to you better. Instead of a number, I will enter, for example, ABC. And the result is ABC, ABC. So this is a string which repeated ABC twice. And as this slide suggests, sometime before I actually do this computation, I need to convert number into numeric format. I can do it separately like this. N will be a new variable, and this will be, say, float of num, and then 2 times n. 2 times n. So that will work correctly. I took my num. Num was a number in a string format, that is a text, and I converted it to a float. Enter a number, 10. The double of your number is 20.0. Since I converted it to a float, there is 0.0. Even if you have a whole number, but it's a float, while printing it, you will get 0.0. Alright, next thing next. We can shorten this code considerably using a so-called nested call. It's not necessary, it may be more difficult or easier. Different people can feel one way or another way. Let's look at this line of code. Int input, give me a whole number. Give me a whole number, this part, between the quotation marks, generally between parentheses of the input, is a string literal prompt. And first, input will execute, and the user will presumably enter a whole number. And then this answer, value will be converted to actual integer, because input produces a string. And hence, using that, I can shorten my code considerably. by using a nested function call, whether or not to use it. In this case, I'm converting to float instead of integer, because I never said that my number should be a whole number. And I'm deleting this altogether. And one last step that I need to do for this to work, squint at it, think for a couple of minutes if you need to. So now my num is actually a float number, and I can double that. All right, and it works as intended. So let's enter 20, double of your number, 40.0. I can shorten it yet again. Let me save it as a second version. I can get rid of this double variable. Sometimes it's good, sometimes it's not. And I can put my mathematical operation inside the print statement and get rid of this altogether. So now my program is down to 2 lines. Enter a number. My number will be 5, and the result is 10.0, which is correct. Now, which one is better? This one or previous one? Well, the answer to that, for short programs like this, I don't really care. I like some standard nested function calls like this one. I will keep using something like this all the time, and that's fine. But you need to know that shorter code may be getting very sophisticated very fast. So how exactly you are going to do it is entirely up to you. This version, version 2, or previous version, version 1, they are okay. And when your code will get longer, you will worry about the practices, best practices. In essence, there is no, for this very little program, there is no difference for me. All right. Now, we already did some little calculations. So, operator is a tool for performing calculation, for example, plus, minus, divide, multiply. Operands are values which we are calculating the operation of. For example, 2 is an operand, num is an operand. And notice an interesting feature of this program. We, as a programmer, don't know what num will be. It is up to the user who will run this program. So you give this program to someone else, and the user enters a number that they want. So num in my code is a variable. It will be defined during the program execution. All right, going back. And whenever you have a result, it's reasonable to assign it to a variable, as I was doing in version 1 of this program, and that's actually, in that regards, it's a more scalable way of doing things. All right, basic math operations: plus, minus, multiply, divide, integer division, remainder, and exponent. Now, everyone knows the first 4. Let's recall what is an integer division. Divides one number by another number and gives the result as an integer. What does that mean? Let's experiment, and I will close this program and start idle in U, because that's the easiest way to do one-liners. Here it is. So I want to do integer division of 15 by 4. And the result is 3. That's interesting. Why is that? That is because 3 is how many times 4 fits inside 15. More precisely, 15 is equal to, and this is like a comment. Python doesn't need to do anything with this information, with what I'm typing. 3 times 4 plus how much to make it true? Another 3. So this 3, the highlighted 3, is a remainder, and this 3 is a quotient. Integer division, you should remember long division from your school days. Alright, so for the remainder when dividing 15 by 4 is 3. Now, next question. What is the quotient dividing 17 by 5? Think about it for a moment. The quotient is 3. And now 17 by remainder when dividing by 5. Think about it for a moment. If you found the quotient, you also found the remainder. For example, do long division 2. What does this mean? Comment. It means that 17 is equal to 3 times 5 plus 2. And this 2 is the remainder. And this 3 is the quotient. It means that 5 fits 3 times into 17, and 2 is the remainder. Okay, so hopefully you have recalled this, and there is one more way of using remainders. For example, to check if the number is even. Is 17 an even number? Even number is the number divisible by 2 evenly. No, it's not. Divisible by 2 evenly means remainder is 0. For example, 16, remainder when dividing by 2 is 0. So keep that in mind. Remainder is a good tool, and we will use it through this class. And the exponent, so let me quickly make an example of that. 2 star 3 equals to 8, because 2 to the power 3 is 8. Remember these things. All of this we will use repeatedly. I did talk about that, and there is an operation precedence, pretty much the same thing you expect from math, and first parentheses, then powers, then multiply, divide, integer division, and remainder, and lowest priority is plus and minus. And if everything is the same, we go from left to right. Okay, now data conversion. Integer times integer produces a result in the format of integer. So operation multiplication, when it's working with integers only or float numbers only, it produces the same type. What if we multiply float times integer? We get a float type expression, and the integer is temporarily converted to float. Best explained on an example. Let me start idle from scratch so that old examples don't bother us. For example, I want to multiply 2.5 times 2. We all know it's gonna be 5, but notice before we actually hit enter and get the result, notice what's going on here. This is a float, this is an integer. My result will be 5, but it will print as 5.0 because the result is always a float. In many cases, of course, when I multiply a float by an integer, I will get a proper float. For example, 2.1 times 3. And here we ran into a little bit of a rounding issue. So the main thing to learn here is that when you multiply a float by an integer, you always get a float. And also, now, an issue that float numbers have, it's not really a big issue because with great precision, it is 6.3 as expected, but somehow there is a 1 in the end. That is because floats are stored in binary format. So 2.1 is not stored precisely. It is stored approximately as a approximate binary approximation. As an approximate binary. And that means it has some decimal. Not decimal, but binary points. Binary means a number encoded by zeros and ones only. And times 3 produces an approximate result, and when it is converted back to its decimal form for our viewing enjoyment, there is some small error in the end. For all the projects in this class, this is not going to be an issue. And there are some precision formats. There are some float formats. Floats are better because they are faster. And precision are better because, well, they are precise, but slow. In any case, don't worry about this. Just don't panic when you see something that is not precisely right. That is the nature of computer calculations. Now, implicit conversion is something that we have seen in this example when number 2 was converted to a float in order to produce a float result. And explicit conversion is when you actually convert, like I did in my previous program, of float input. So there I converted to float explicitly. Conversions must be explicit when data can be lost. For example, int of 2.7 equals 2. Actually, I'm going to double check if this is still the Python behavior, because these slides were written a while ago, and also sometimes you have to do it just to see that it's right, or go and read in the documentation. Yep, that's still how it works. More print tricks. So the AND and the SEP, that's what we will deal with. Okay, so first of all, let me start a new file. I will have a program here which will say hello. That is the first string literal. And then world, second string literal. And I will copy paste it a few times. You probably wonder why am I doing that. I will have to save it. And I want to put them in the same printing tricks. So the same text. And if you just curious about any function, you can type in the name of a function, open parentheses, and here is your prompt. There is a separator if your printing statements are separated by comma. What the separation when it does the printing will be. Alright, so in the first case, well, first of all, what you can notice from here, default separator is a blank space and end is a /n. I will talk about it later. Alright, so sep will be any kind of string. For example, triple star. First time. Second time, I'm going to say sep is certain escape character. And third time, I will say that sep equals to doesn't really matter. Didn't think about the third example well. Let us try to see what happens to printing statements. Here we are. First of all, First printing statement, hello world with separator triple star. So in one printing statement, if you're printing several values, comma separated, when you print, after each value, there will be a separator symbol. In this case, triple star. In the second case, it's not triple star, it is a so-called escape character, new line character specifically. This is basically telling the string advance to a new line, and that's what happened over here. So the result of the second printing statement on line 2 over here is hello world, but the word world advanced to a new line. And finally, third example, for hash symbol or sharp symbols, that is a separator for the third line. So this is an escape character, \n. In general, there are plenty of escape characters, but the most useful ones are here. \n, \t, single quote, double quote, and \\. Causes a \ character to be printed. So that's another good example. Let me modify this. \, rerun. The last line has a single \ as expected, instead of, because the first one is escaping the default value of \. Now, let's go into a little bit of detail. So by itself, we sometimes want to have a letter as a part of our string literal. That's okay. Then, by itself, we might want to have a letter T. And escape characters is actually doing something else. It's just a code to do something else. In this case, to advance to the next line. In the second case, skip over to the next horizontal top position. Top position is the next 8th, starting from the beginning of the line position, like 8th, 16th, or 32nd, and so on. Causes a single quote mark to be printed. Okay. Well, I would like to print exactly this string. I'll learn Python this semester. By the way, I will not have to retype it. I can do print, and I'll try to do it by copy-paste, and this is an error. Like, use the color coding. In different IDEs, color coding is different. This is an error. First of all, I is not a part of the string. Strings are color-coded in green by default. I need this to be a string, so I need quotation marks around it. So starting quotation mark and ending quotation mark, and it still has an issue. Now it thinks that the letter I is a string in its own right, and this is something like variables, who knows what. And here is another string, starts and never ends. Let's try to run this. That's one way how IDE can communicate to you that there is an error detected on line 2. By the way, there is a way in the options to configure idle, change the size of the font. Let me do 14 maybe. And also, I might want something else from here. So first of all, the font got bigger, maybe easier to see. And still this doesn't work. And the problem is that Python reads this code and it sees that the highlighted part is a string, and in between there is something, and there is another string here starting, and it's not even sure how to color code that. Let me use the escape character. This means, these two symbols mean that I want in my string just the quotation mark. And now this will work as intended, precisely. So I'll learn Python this semester. There is another way to make it happen. Without escape character, but with double quotation marks. Then I can just do the apostrophe and the result will be precisely the same. Let me resize the window or just restart the idle. Here it is. The result is exactly the same. If you have double quotation mark, then inside marking the beginning and the end of the string, then inside you can use single quote. Now you cannot always pull a trick like this, so you will need escape character for quotation marks and other escape characters. Okay, so we will be coming back and using them a little more. Now, string concatenation. I already showed you an example when I tried to double the string. So, double the string hello, the default Python behavior is actually concatenate the string with itself. I can also concatenate hello, a string hello, with world, and it is hello world, but in one word with no blank space. Now, if I add blank spaces over here, actually I cannot do that because it's a console, so I'll try again. Fake try again, that will not work. Alright, that will not change anything. The blank spaces over here don't matter. In the middle of your programming statement, blank spaces don't matter. I can have as many as I want. However, if I have a blank space over here, it does matter. It's a part of a string. Alright, so finally, there is one more tool we need to work on, that is format. It takes two arguments. That's a function, first of all, which we know. It has a name and parentheses. It takes two arguments. Numeric value to be formatted. Format specifier, a specifically chosen string. Okay. Let me do it in idle. So my value x will be 2.123456.7. And I will format it in different ways. For example, I will say format, open parenthesis, and here is my prompt. I will format x, and we will use format spec .2f. So this is 2 decimal points. So it cuts off at the second decimal point. Let's try it again. Switch it to 5. So it cuts off after the 5 digits right to the right of the dot. Alright, so it doesn't round. Notice that format doesn't round, but it cuts off nicely. Now, if we were talking about million dollars, see, it gets difficult to measure how many zeros are there. You have to actually count. So this is a million. So for printing, you can do this. Comma, D. And it is printed in a format that is convenient. After every 3 digits, there is a comma. There is a lot of ways to specify the printing format. I'm not really worried too much about it. We will do it sometimes because we don't want to see way too many decimals in the end of our computations. It's a useful little tool. Well, let us do some of the examples. And by the way, going back to the book, there is a lot of examples in the end of the chapter 2 and every other chapter that we will cover, so feel free to do that. Maybe I'll skip the first one. And I will do the number adder. So script to ask the user for 2 numbers displays those 2 numbers, and then they are added together. Here we are. I will close this and just save it. Number adder. Okay. For clarity, what I can do is copy paste. Doesn't always work because there can be some issues with format in copy pasting. But this is a description. This is a multi-line column. Multi-line column comment. That's what I'm going to do. And I'm going to create a variable num1 that is input. Enter the first number. And you probably already saw an error and you are yelling at the screen like crazy right now. Errors are natural, they happen to everyone. Some errors will be noted when we actually run our program, test our program. And I will say the sum is the value num1 plus num2. I will call the variable sum, and that will be a bad idea. Because sum is a function. In general, don't call your variables by the same name as a function. So I'll just say s for brevity. The sum is s. And now the moment of truth, why there is an issue here. What's the problem? All right, let's do this. Testing our program. Whoops, unexpected indent. I really did not plan this, and indentations matter. There shouldn't be some random blank spaces before a programming statement. That is a rule. Okay, good thing that you saw that, even though I did not plan that. And now the unexpected indent. What's wrong with me today? Run. There are environments that are actually a little more flexible about that, but let's work with idle. Enter the first number, 5. Enter the second number, 2. Oops, the sum is 52. Not what the math would tell us. What's the problem? Well, of course, we ask the user for an input. By default, this num1 is a string, so the value 5 is actually a string value, not a numeric value. Let's convert it to a float number. Let's run, see what happens. Enter the first number 5, the second number 2, and oops. So traceback call, type error. This is sort of errors that you will get. This is normal. And part of your job and training this semester is to learn to understand these error messages and deal with them accordingly. Traceback shows where the error happened. It actually in line 1, again, I was going to switch on the enumeration of lines, but for short programs we just count, and also it quotes the line over here. Something went wrong here. What exactly went wrong? Type error. Unsupported operand types for plus, float, and string. So my operation sum does not support arguments float and string, so it cannot add float and a string. And I go back to my code and I see that I forgot to do the float in the second one. And here we are, now it works. Enter number 5 and second number 2, and the result is 7.0. It's converted to float. Nowhere did I say that my numbers should be whole numbers. So if I were converting them to integer and then the user would put in 5.1, the program would crash. So that is some point that I'm going to do to make a little later. All right, let's keep working. Well, Celsius to Fahrenheit converter. Feel free to look beyond and look at Python language documentation. It's very nice, although initially it looks like it's over the top of your head. There is so much verbiage in there, but with experience you learn to read it and reference to it. List of built-in functions for your entertainment. Some of them we will talk about, but it's a huge list. I never actually checked out the whole list. And some little challenges, you can do them. These ones you can do by Googling or by thinking really hard about it. And let's go back and actually do Celsius to Fahrenheit. So this is a way to convert, and we want to convert Celsius to Fahrenheit. All right, now new file. That's another way to create new files. Save as. Celsius to Fahrenheit. And all I need is this formula. 9/5C plus 32, where this is temperature in Celsius. And I can copy-paste that to have some sort of documentation about my little tiny program. Doesn't take much time to do, but is helpful in case somebody looks at it later. So I need to ask the temperature in Celsius and convert it to Fahrenheit. So Celsius equals to, and I'll try int input to convert it to integer. Input, enter the temperature in Celsius. Then use the formula that I showed you that is on the slide. How convenient. And Fahrenheit will be, let's go with capital F, consistent with the formulas on the page in this case. 9 divided by 5 times C plus 32. Now, if you want to be super safe, you can put parentheses around 9 over 5, but I know that division has a higher precedence than multiplication, so this operation will be computed first, then multiplication, and then addition. And finally, print in Fahrenheit the temperature is, by the way, notice that this is a string literal and this is a volume. Alright, let's try this and run on a couple of inputs. Think what can possibly go wrong. As a programmer, that's one of the things you do. Something is not quite good here. So maybe stop a video, try to ponder what's wrong. Alright, to the temperature in Celsius, 10 degrees. The corresponding temperature is 50. Well, that works. Do the math in your head, it works. Seems to be working perfect, so a careless or naive person will leave it there. And if you don't see what's going on, rule of thumb, try different inputs. Okay, 21 degrees Celsius. I think I misspelled Celsius pretty badly. Good thing I'm not paid for my spelling skills. Alright. So 21 degrees. What do you think can go wrong? Let's see. Actually, nothing goes wrong yet. What can possibly go wrong? Try again. And here we are. I'm just going to make an example that will crush it. 21.5 degrees Celsius. Yay! Something went wrong. Whenever you have an error message, this is a learning opportunity. You Google this error message, not this specific thing, and not this thing, but value error, invalid string literal for int with base 10. What does it mean? What does trigger it? But let me just talk through it. First of all, trace back. We were running this file. If you start reading this completely, this is actually the address on my machine where this file is. Line 2, this is the line quoted here. And the value error, the literal for integer is invalid, 21.5. So the literal 21.5 as a string cannot be converted to integer, and it's smart enough to actually warn us about it. So what should I do? I tried to convert an integer, the number that was not an integer. Alright, I should convert to float, unless you're asking for an integer value, which you should specify in the prompt. You cannot expect to get an integer here. So now this is a good program and it works. Let's 12.34 gives temperature with good precision. Too much precision. Feel free to use a format. How do we use a format? I want to format this and I will do a nested function call. So inside my print function, I'm calling format function. And I will round my Fahrenheit temperature to the first decimal. And if I'm right, point to F, point to 1F, This is how we do it, and this is a call for the format function. And now I need to close my parentheses, the print parentheses. Let's see if I'm right. This should round the results to 1 decimal, not round, but cut off the results to 1 decimal point. Yay! So now this looks a little more readable, because honestly, most of the time we wouldn't care for decimals altogether. Alright, in this case we left 1 decimal